One of the most important things you're going to learn as you develop your programming skills is how to read code like a computer. The computer has a very specific, systematic way of knowing which line of code to execute next. And that system is called control flow. Let's take this pretty basic class as an example. It's going to start with the very first line in the main method. The code knows to run everything on this line until it hits that semicolon before it moves on to the next line. Once it's moved on, it's going to run everything on that line up to the semicolon, and then it's going to repeat. Once it gets here and it finishes this line, as soon as the code reaches that closing curly brace, it knows the main method's over and it's going to stop running your code. This actually is pretty simple to follow along with. However, things get a lot trickier when you introduce other methods. Let's look at this example. Now main has a bunch of method calls inside of it. So how does the computer deal with that sort of control flow? Well, it actually deals with it pretty similar to how it did before, line by line, except now we're introducing the concept of jumps. The computer is going to start at the very first line in main, just like it would normally. But it sees that this is a method call, which means it needs to go out and find the method that this is calling. It's going to jump down to where that method is declared, and then it's going to run the first line of that method. Then it's going to run the second line, and it's going to run all the way through until it gets to the end of that method. Once it's gotten to the end of that method, it's going to come back to where it left off in main. And then it sees that's a method call, and it's going to go do the same thing but jump off to a different method. So it's still going line by line. However, every time it sees a method call, it jumps to wherever that code is and then runs that line by line until it sees the closing curly brace when it comes all the way back. Okay, we can go deeper. What about when methods call other methods? Well, again, you can just extrapolate this algorithm one level deeper. Let's take this for example. We have a main and it's got some direct printlns in it, but it's also got a call to other methods. And then method 2 has a call to method 1 inside of that method. Here's a skeleton of our code. We're going to start with this very first method call. And it's kind of like the computer jumps over, finds that code, and then it's going to run everything inside that method. So there's our first line of output. Then it's going to come back to exactly where it left off. The next line is another method call, so it's going to do that method. It's going to produce that line of output that's inside that second method. But then it sees another method call, and it's going to jump one level deeper, and it's going to run everything inside here before returning to where it last jumped, which is back to that second method. Then it's going to pick back up there and finish that line in the second method. Now that it's done, it goes right back to main. And then finally, we finish with whatever was left in main. We hit the closing curly brace for main, and our program is done. So if you just take time to slow down and look at it line by line, it's pretty easy to think like the computer. It's just sometimes it's hard to keep track of. But don't worry, there's lots of different tools within your integrated development environment to help you do this. And sometimes adding a println here or there can help you keep track of how the code is executing. But until you get really good at it, it's really good practice to do it by hand and make sure that you're following along and really understanding how the computer is reading your code.